All right, this is Team Libra's presentation on space exploration.
Starting back in the 1950s while working for the U.S. government, German rocket pioneer Wernher von Braun developed a practical plan for Martian journey, which included a massive expedition involving 10 4,000-ton spaceships and 70 crew members. Technology and cost were two problem areas. Von Braun overlooked effects of prolonged weightlessness, radiation from solar flares, and the whole idea was based on a poor understanding of Mars, with thin atmosphere making it more hostile than he knew. Costs for his Mars trip were immense, preventing the trip from materializing, but it did spark ideas from governments, companies, and private groups to try. In 1958, the U.S. began the Explorer program to catch up with the Soviet Union's launch of Sputnik. Explorer was launched by the Army Ballistic Missile Agency and was later transferred to NASA. The picture on the top right corner is a picture of Explorer 1 that launched in January 31 of 1958. In total, NASA's made more than 1,000 unmanned missions into Earth's orbit or beyond. The Pioneer program in 1958 continued on with the Mariner program in 1962, were some of the first to investigate planets in our solar system. NASA sent many surveying spacecraft to the moon with Surveyor, Vikings, and Voyagers. NASA started cooperating with other countries and also launched probes and observatories with telescopes with the ability to scan and monitor X-rays, gamma rays, and infrared. NASA then launched over 200 manned flights, with 2 ending in failure, causing the death of the entire crew with the Challenger in '86 and Columbia in 2003. Apollo 1 in 1967 lost 3 crew members, but it never launched. The Mercury program was the first with a U.S. crew launching 6 missions. The Gemini program launched 10 missions, helping to advance technology and the knowledge that led to our moon landing in 1969 with the Apollo program. NASA sent a Skylab in 1973 and the first American space station. In 1975, we joined the Soviet Union for the Apollo-Soyuz test project. The Space Shuttle program ran from 1981 to 2011 with 135 crewed missions. It was the first time that we reused a spacecraft. Now, from all of these missions, we've had a lot of technology that we've been able to use in our everyday life. Starting with lightweight materials used for spacesuits. They've been able to use them for firefighting suits with lightweight breathing equipment and protective gear that protect our firefighters from smoke. Also, the Warp 10 LED is a really great product that developed from the experiments that NASA had with LED technology. It increases local blood circulation and can relieve muscle spasms, promote muscle relaxation, and aids in joint relief. Also, relief of pain from arthritis. The Navy is using it as a non-invasive soldier self-care device that is used by the frontline forces with first aid for minor injuries and pain, improving endurance during combat. We also have technologies for camera phones and everything from remote starting your oven, as well as lightweight materials, along with other companies to make great prosthetics that are comfortable and lightweight. Also, using infrared technology that NASA had developed for measuring the temperature of stars and planets, they were able to make an oral thermometer weighing only 8 ounces that measures the energy emitted from the eardrum the same way it did from planets. Really, we've gotten all this technology from all these space flights. Imagine if we would have stopped after we landed on the moon. What computers would we be using? What technology would we be stuck with?
All right. So for the political ramifications, extended international cooperation is absolutely vital. So interspecies politics are extremely unlikely. However, these international ones are the most common scenario that we see today. It first began during the Cold War with a Cold War battlefront for space. That was between the USSR and the USA. They were cooperating together to create the ISS, the International Space Station. That included countries such as Europe, Japan, Canada, America, and Russia. And was used to put together the International Space Station to help further scientific research with the different countries in our planet. Marina, I can't say her name, Marina Benjamin said that the impact of seeing the Earth from space focused our energies on the home planet, dramatically affecting our relationship to the greater community of mankind. A side note is that potential encountering of new life is definitely an add-on for this said scientific research. There's a lot of economic gain to be seen in this as well. Spaceflight is definitely a prime candidate for political economic endeavors. The scientific and economic factors provided for more significant motivations for nations increases the particular interest in developing using microgravity facilities and developing their niche and capabilities in space. The Bush plan was in 2004, and that was when NASA was increased in a budget of $1 billion over the next 5 years. This was to help astronauts have the first return to the moon and later a trip to Mars. Howard McCurdy said, though, that if we want to go to the moon and Mars, we should be shutting things down now, not waiting for the next 5 years. This plan was originally conceived in 1989, but fell apart when NASA came back with a budget of $400 billion price. Since then, it has come down significantly in cost, and the first step in this program was to establish the ISS. The initial cost paid for the ISS was $8 billion. However, that quickly escalated to $23 billion, and the price has gone up even further since the Columbia disaster and other factors, which came to a total cost of about $65 billion. Since then, the Space Shuttle program was winding down, and Bush is getting the credit for launching this bold new adventure of going to the moon again. However, this program's name was Constellation, but in 2011, Obama passed a bill through Congress to eliminate the Constellation program that would send humans back to the moon by 2020. This is a frequent occurrence in the politics of NASA, as they are controlled solely by the government, which means that their agenda switches about every 4 years. NASA's new goal was moved to spending about $6 billion to pay private space groups to help develop and send rockets into space, and has since then shifted their primary focus to research over actual deployment.
Now moving into the cost of space exploration, it's obvious that unmanned space flight is much less expensive than manned space flight, and to prove that, I have a couple examples of the drastic price difference. So possibly the most well-known manned space program would be the Space Shuttle program. It was NASA's fourth human space flight program. It ran from 1972 to 2011 with its first crewed flight in 1981. Its missions were to bring large loads into orbit, including bringing things to the International Space Station. It had 133 successes and 2 failures, which would be the previously mentioned Challenger and Columbia. Its original cost estimate was $54 billion, and this is with inflation taken into account, because originally when it started the price would be different because it was in 1972, but in 2011 dollars it was $54 billion, and the actual cost in the end was $196 billion. Some places saying $209 billion, but either way, it roughly rounds to $7 billion annually, and about $450 million per mission. NASA dedicated a lot of money to this program because the fact that it was unmanned made it very interesting to the public. Now for unmanned flight, we have NASA's Messenger, which was a Mercury probe. It orbited Mercury from 2011 to 2015. It cost approximately $280 million, which was less than the original proposal. And moving into SpaceX, it was founded by Elon Musk in 2002. Its eventual goal is to colonize Mars, and there is supposedly a flight going up to Mars this year that is supposed to cost about $300 million, and they also want to visit the moon this year, which would cost roughly the same. So if you talk about manned flight, we're usually in the billions of dollars, and quite often it ends up costing more than originally planned, whereas unmanned is more in the millions and often costs less than planned. And as far as SpaceX goes, I found a quote that says, "Founder Elon Musk wants to use the company to get to Mars, a vision he's detailed in a speech titled 'Making Humans a Multiplanetary Species.' In that speech, he said, Right now we are estimating about $140,000 per mission for the trip to Mars. If a person plus their luggage is less than that, taking into account food consumption and life support, the cost of moving to Mars could ultimately drop below $100,000.
Alright, so now that we know the differences between the costs of manned versus unmanned, what are the other pros and cons? For manned, if we send up geologists to the moon again or Mars, geologists would know exactly what to study and what to ignore on the landscape. They could make very quick decisions, wouldn't have to wait on HQ, and it would be very good for the morale of our country. Plus, it's also better for what would be good layout if we wanted to expand into space. Where are good places on those planets? However, to send man into space, the spacecraft has to be heavier. It has to carry their food and other supplies, their oxygen, and it has to actually be able to, house the humans for however long they are there. This costs more, but however, there's still that risk of death. Also, there's a very limited exploration window of how long they can be up there, when we can send them, when we can bring them back, and how safe it will be for them. Unmanned, there's no risk to human lives. There is no need for a separate capsule because the robot or the rover can fly itself. It can stay on the planet longer, usually for its whole life. However, if we wanted to spend the extra money to bring it back, we could bring back rock samples if we wanted. And the robot can also check that the planet is livable. However, robots don't think for themselves. We have to tell it what to do, and communication between the two is very, very slow. Robots can't differentiate between landscapes like the geologists can, and the public is not at all very interested into robots going into space compared to humans going into space and exploring. So which would really be better?
Well, our group collectively believes that both manned and unmanned space missions are necessary. Definitely unmanned missions that would be cheaper for fact-finding trips, but our group agrees with many of NASA's leading scientists that champion human exploration is a worthy goal in its own right and is critically important part of our space science in the 21st century. To close with a quote from Stephen Hawking, "Robotic missions are much cheaper and may provide more scientific information, but they don't catch the public imagination in the same way, and they don't spread the human race into space, which I'm arguing should be our long-term strategy. If the human race is to continue for another 1,000,000 years, we will have to boldly go where no man has gone before."